Welcome to Consforc, your go-to spot for decoding the data that's changing everything. No jargon, no fluff, just smart conversations that make numbers actually make sense. Let's jump in and see what the data has to say.
Welcome back to our deep dive into the world of data science and analytics. Today, we're exploring why data scientists and analysts are absolutely critical in today's data-driven world. It's no exaggeration to say that data is the new oil, and those who know how to extract, refine, and use it effectively hold the keys to future success.
Exactly. Over the past decade, we've seen an explosion in the volume, velocity, and variety of data generated by everything from smartphones to sensors and factories. The International Data Corporation estimates that by 2025, the global data sphere will grow to 175 zettabytes. That's 175 trillion gigabytes. This staggering scale means companies must invest heavily in data expertise to avoid being overwhelmed or left behind.
Right. But it's not just about having data, it's about making sense of it. That's where data scientists and analysts come in. They have the skill set to transform raw data into meaningful insights. For instance, a data scientist might develop a predictive model to forecast customer churn, while an analyst might identify trends in sales data to inform marketing campaigns. Both roles are essential and complementary.
To give you a sense of scale, LinkedIn's 2024 workforce report ranked data scientists as one of the fastest growing and most in-demand roles globally. Companies across industries are actively seeking talent, but there's a significant shortage. According to IBM, the United States alone could face a shortfall of over 150,000 data science professionals in the next few years.
And that shortage is impacting companies' ability to leverage their data effectively. McKinsey reported that while 90% of executives say their organization wants to be data-driven, only 20% have successfully embedded analytics into decision-making. The gap is often a lack of skilled data professionals who can bridge data science with business needs.
Let's unpack why this bridging role is so vital. Data scientists don't just write code. They need deep domain knowledge and the ability to communicate complex insights clearly to non-technical stakeholders. Without this, even the best analytics models won't be used effectively.
I've seen this firsthand in healthcare organizations. Data scientists may build sophisticated models predicting readmission risks, but if doctors and administrators don't trust or understand those models, they won't integrate the insights into patient care workflows. That's why soft skills and business understanding are just as important as technical prowess.
Absolutely. The demand for data professionals spans many sectors. Take retail, for example. Amazon's recommendation engine, which drives about 35% of its sales, relies heavily on data science. They analyze purchase history, browsing behavior, and even seasonal trends to personalize suggestions.
That personalization extends beyond just e-commerce. Media streaming platforms like Netflix and Spotify use data science to curate content uniquely tailored to user preferences, increasing engagement and retention. The impact? Netflix reportedly saves over $1 billion annually by reducing churn through personalized recommendations.
And it's not only about customer-facing applications. Behind the scenes, companies use predictive maintenance models in manufacturing to prevent costly downtime. Rolls-Royce, for instance, collects real-time engine data to predict when parts will need maintenance, improving safety and reducing costs.
Similarly, agriculture has seen a data revolution. Farmers now use satellite data, IoT sensors, and weather models to optimize irrigation and forecast crop yields. This precision agriculture can boost productivity by up to 30% while conserving resources.
Let's also consider finance. Algorithmic trading, credit risk scoring, and fraud detection all rely heavily on data science. Modern fraud detection systems analyze transaction patterns in real time, identifying anomalies that humans would miss.
Sports analytics is another exciting area. Teams analyze player performance data, biomechanical sensors, and even opponent strategies to gain a competitive edge. The use of data has evolved from simple stats to highly advanced AI-powered insights.
These examples illustrate the massive breadth of data science applications, but they also highlight challenges. One of the biggest is data quality. It's often said that data scientists spend 80% of their time cleaning and preparing data because bad data leads to bad decisions.
That's true. Garbage in, garbage out.
Poor data quality can lead to flawed models and misguided business strategies. That's why data analysts play a critical role in validating and contextualizing data before analysis.
Ethical considerations are also paramount. Bias in training data can result in unfair algorithms, say a hiring tool that favors certain demographics due to biased historical data. Responsible data science involves auditing models for fairness and transparency.
Explainable AI, or XAI, has emerged as a solution to this problem. It allows data scientists to open the black box of complex models and explain how decisions are made, which is crucial in regulated industries like healthcare and finance.
Let's talk about education and upskilling. With demand so high, many companies are investing in training their existing employees. Upskilling programs help staff across departments understand analytics basics, which in turn improves collaboration with data teams.
Data literacy is becoming a core competency, not just for data professionals, but for all business roles. When managers understand KPIs and basic statistics, they're better equipped to make data-informed decisions.
And technology is evolving to support this shift. Augmented analytics uses AI to automate data prep and even generate insights, making analytics more accessible to non-experts while allowing data scientists to focus on higher-value work.
Looking ahead, integration of AI, machine learning, and real-time streaming data is making analytics faster and more predictive. Companies can respond to market changes almost instantaneously.
At the same time, privacy regulations like GDPR and CCPA require data scientists to embed privacy and compliance into their workflows, balancing innovation with user rights.
The future of data science is bright but complex. Professionals need to balance technical skill, ethical responsibility, and business savvy. They are the linchpins of today's data-driven economy.
So whether it's transforming patient care, optimizing supply chains, or creating personalized customer experiences, data scientists and analysts are indispensable.
And as the data landscape grows, their role will only become more critical. Continuing our discussion, let's dive deeper into how data science is reshaping specific industries in detail, starting with healthcare. Beyond predictive models for readmissions, we now see the rise of genomics and personalized medicine powered by data science.
Yes, the Human Genome Project generated massive data sets, and with advances in sequencing, it's now possible to analyze a person's genetic makeup quickly and affordably. Data scientists develop algorithms that identify gene variants linked to diseases, helping doctors tailor treatments to individual patients.
This is a paradigm shift. Instead of the traditional one-size-fits-all approach, treatments can be customized based on a patient's unique biology. For example, in oncology, data-driven models predict which chemotherapy drugs will be most effective for a given tumor profile.
Another area is medical imaging. AI-powered image analysis assists radiologists in detecting anomalies like tumors or fractures with higher accuracy and speed than ever before. The algorithms learn from thousands of images, identifying patterns invisible to the human eye.
On the operational side, hospitals use data to optimize staffing, bed allocation, and supply inventory. During the COVID-19 crisis, real-time data dashboards helped health systems monitor ICU capacity and ventilator availability, crucial for resource planning.
Telemedicine also relies on data science, analyzing patient interactions and outcomes to improve virtual care. Plus, wearable devices generate continuous health data streams that can signal early warning signs of health issues.
Shifting gears, let's explore how retail uses data science beyond personalization. Inventory management is key. Predictive analytics help anticipate demand spikes, preventing stockout or overstocking, which reduces costs and improves customer satisfaction.
Pricing optimization is another powerful application. Retailers use dynamic pricing models to adjust prices in real time based on competitor pricing, demand elasticity, and inventory levels. Airlines were early adopters, but now this is standard in many sectors.
In sports, advanced analytics have revolutionized talent scouting and in-game strategy. Teams analyze biomechanical data to tailor training and prevent injuries. Coaches receive real-time analytics during games, enabling strategic substitutions and play calls.
Sports broadcasters also use data analytics to enhance viewer experience, displaying live stats and predictive insights during games, which increases fan engagement.
Manufacturing has entered the era of Industry 4.0, where IoT sensors and data analytics enable predictive maintenance, quality control, and process optimization. Data scientists develop models to predict equipment failures, avoiding costly downtime.
Energy is another sector leveraging analytics for efficiency. Smart grids use real-time consumption data to balance supply and demand, incorporate renewable sources, and reduce costs. Data scientists model energy usage patterns and forecast demand spikes.
Let's not overlook government and public services. Cities use data analytics for traffic management, public safety, and urban planning. Predictive policing models aim to allocate resources more effectively, though they raise important ethical questions about bias.
Public health agencies analyze epidemiological data to track disease outbreaks and plan interventions. Data scientists develop simulations to evaluate the impact of vaccination programs or social distancing policies.
In education, analytics help tailor learning experiences to individual students. By analyzing performance data, educators identify knowledge gaps and adjust instruction accordingly.
Massive open online courses, MOOCs, use data to improve course design and student engagement, increasing completion rates.
All these examples highlight that data science isn't just a technical function, it's a strategic capability embedded in every sector.
That brings us to the skills data professionals need today. Beyond coding and statistics, communication, ethics, and domain expertise are crucial.
Yes, the ability to translate complex data into stories that inspire action is vital. Data storytelling bridges the gap between analysis and decision-making.
Ethics cannot be an afterthought. Responsible data science means scrutinizing data sources, avoiding bias, ensuring privacy, and being transparent about model limitations.
Domain expertise ensures that insights are relevant and actionable. A data scientist working in finance needs different contextual knowledge than one in healthcare.
Upskilling is essential. The data landscape evolves rapidly with new algorithms, tools, and regulations.
To meet demand, many organizations are investing in training programs and partnerships with universities to grow talent pipelines.
Additionally, democratization of analytics tools enables more people to engage with data, enhancing organizational data literacy.
But with democratization comes risk. Without proper training, misinterpretation of data can lead to poor decisions. Hence, professional data scientists and analysts are still needed to validate and guide data use.
Looking forward, integration of AI with analytics will enable autonomous decision-making in areas like fraud detection and supply chain management. Edge computing and 5G will facilitate real-time analytics in IoT devices, unlocking new applications in smart cities and autonomous vehicles.
Privacy-preserving techniques like federated learning will allow companies to build models without compromising sensitive data.
The future is exciting, but demands vigilance to balance innovation with ethics.
To wrap up, let's discuss why data scientists and analysts are not just nice to have, but mission critical for organizations aiming to thrive in the digital economy.
The digital transformation wave sweeping industries demands data-driven agility. Companies must rapidly adapt to changing consumer behaviors, supply chain disruptions, and technological innovations. Data professionals enable this agility by delivering timely, accurate insights.
Take the retail apocalypse as an example. Many brick-and-mortar stores failed because they couldn't respond to shifting consumer preferences fast enough. Retailers who invested in data analytics optimized omni-channel experiences and personalized marketing, enabling them to survive and even grow.
In finance, real-time risk analytics allowed institutions to navigate volatile markets during economic downturns, preventing losses and identifying new opportunities.
Healthcare organizations that adopted data-driven patient care models improved outcomes and reduced costs, demonstrating the tangible benefits of analytics.
Looking at government, data-driven policies enable better resource allocation, improved public safety, and enhanced citizen services.
The growing complexity of data ecosystems means organizations can no longer rely on intuition alone. Data scientists and analysts provide the expertise to harness complexity into clarity.
Moreover, they act as ethical stewards, ensuring data use aligns with societal values and regulations. With the continuous emergence of new data sources, like wearables, autonomous vehicles, and augmented reality, demand for data expertise will continue to soar.
And as AI evolves, data scientists will shift towards more creative, strategic roles, designing AI systems, interpreting outputs, and guiding ethical use.
To sum up, data science and analytics are no longer peripheral. They are central pillars of modern organizations.
Companies that recognize and invest in this will not only gain competitive advantage, but also contribute to shaping a more informed, efficient, and ethical world.
And that's why data scientists and analysts are among the most important professionals of the 21st century.
Thank you for joining us on this comprehensive exploration of data science's vital role. Stay curious, stay data-driven.